Thank you very much. Yeah, so good morning, everyone. Good morning. My name is Thomas Steiner. I come out of this beautiful city, so I'm not a stranger to here. Oh, thank you for the mention. Let me quickly turn on Do Not Disturb mode. Here we go. Yeah, so my Twitter name is here, so thank you for mentioning me again. You should probably follow me or decide after the talk if it's worthwhile. So today I'm going to talk about what's next for the web. The alternative title for this talk could be Exploring About Flags. This is a talk that I'm going to give in India and in China at the Google Developer Days there in a couple of days actually. And it's built upon a talk that I gave at Google Developer Days in Krakow. So this is really the most up-to-date things. You're going to see it before India and China. Figure that. So what's next for the web? So this is like a collection of topics. So there's going to be a lot of content. It's probably too fast and too much, but there's always links. So you can take your cameras out and take photos of the links and catch up afterward. So just a fair warning, there's a lot of content coming. So first big topic, progressive web apps. And our first actual topic is then immersive full-screen PWAs, progressive web apps, PWAs. Because in most of the cases, your PWA deserves a lot of screen real estate. Some of you who have been around for a bit may remember the PWA paperplanes.world. I have fond memories of everyone in the Google canteen in Hamburg throwing paper planes with their phones like this. So if you've been around, this will definitely ring a bell, I think. So it's a full-screen PWA. And if you look close, you can see that on the top bar, there's no network, there's no clock. It's a game, or supposed to be a game. So they made it really look and feel completely immersive. So they took over the entire screen. It doesn't make sense in all cases, but for games like this, it definitely makes sense. And how do you do that? Well, in your web app manifest, there's now a way to set a property display to full screen, and then your phone will actually do just that. Most commonly, you will have something like standalone, which will still keep the top bar. But if you actually program a game or you have a lot of reasons to go full screen, then it definitely can do this now. So that's newish. Something that is also new and even more impactful is what we call improved add to home screen, because it makes your PWA behave more like a real app. What do we mean by that? Well, first of all, if you look at the animation here, you can see how after installing this PWA, it's now part of your regular apps. So in the app drawer on Android, you can now just search for it and it will show up alongside all your native apps like Gmail, like YouTube, like whatever. It's now behaving and looking like a real actual app. And in your web app manifest, you can now set a scope. And if Android, with an intent filter that it creates, recognizes that your PWA is dealing with something that is within its scope, Android will directly jump into your PWA. So if you have a specific application that takes care of /flights, for example, then your PWA can take links and from anywhere you can connect to your PWA. So that's a pretty powerful feature. Something that's also newish is the WebShare API. It has now really landed in browsers. A lot of you will recognize this situation. So you have an article like here on Spiegel Online, and because you, or actually they, want you to share this article, they place a ton of share buttons. But typically, well, first of all, it's a lot of wasted screen real estate, because you can see it's an entire line of icons, and most of them you will never ever click. But actually, if you decide to share this article, in many cases, your favorite network, in this case, maybe Xing, for example, might not be there. So it's like, no, come on. They placed all these icons, but I want to share it on Xing, and Xing is not there. So that's kind of really not ideal. And this is the situation that the WebShare API tries to solve, because now it can integrate into the native sharing dialog. So you have a very simple web API here. You can see navigator.share, and then you give it an object title, text, and URL. And then it's all promise-based, and you can, from there, directly tap into the native systems sharing dialog. And this is something that people can customize. So if I am a Xing user, I can definitely place Xing first and center in my list of social networks and directly share from there. So this is really the system dialog that you can completely control as a user. So a huge win for the web because you can just make it your sharing experience and not their sharing experience. Web Share API now live in browsers. Push notifications. We've just seen one in the integration. This was actually a native push application from my Echo phone app that I'm using on this device. But your web push notifications are now on macOS no longer aliens. So on macOS, they're now part of the native notifications, which means, thankfully, by now, they will respect the do not disturb system setting. So before, they were kind of emulated, look alike native, but actually they were not. So whenever you gave a presentation, for example, there was no easy way to get rid of the push notifications. And now you can just use the system setting, do not disturb, and they will just behave like native notifications. So huge win. Something a little bit more technical, actually a lot more technical to be honest, is navigation preload. This is something that is an origin trial. So in Chrome, we have trials where we just test out ideas with partners. In this case, this came from Facebook, who noticed that if they have a service worker in Facebook.com, which is something that they actually do have. So if you haven't noticed, Facebook.com makes heavy use of service workers. They noticed that on their page with their load, and you know that Facebook is not just Facebook.com, it's also every like button, every whatever button. So Facebook is on essentially a lot of publishers' pages. They noticed that, well, their service worker takes a lot of time to boot. So essentially, when you imagine what is going on, you can see in this little diagram here, the yellow part is the service worker boot time, and then the blue bar here is the navigation request. So what happens is when Facebook want to get requests captured via the service worker, in the majority of cases, they couldn't really because the service worker was just taking too long. With the new navigation preload, they kind of parallelized that task. So while the service worker was booting, they could already capture some of the requests that were going on. And like that, for example, make them available for offline, or actually even check if they have the request already. So from a code point of view, what is going on here? Essentially, in the first event, so sorry if you're new to service workers, this is probably diving in very deeply, very spontaneously. You have the activate event. And commonly what you would do is you would just, activate the service worker, meaning clean up caches and so on. But now with the navigation preload, another thing that you can do during the activate event is activate navigation preload. So you can see here we're doing feature detection. So if self-registration navigation preload is not there, we just return. So we feature detect. But if it's there, we can just await the enablement of self-registration navigation preload. So in the activate event, we have enabled navigation preload. And this allows us then, in the fetch case, so whenever something is being fetched from the service worker or in the service worker, we can then check if maybe we have this response already as a preloaded response. So going back, sorry, this was I think just in the moment when you took the photo, but I will get back to the slide. So just in the case where we have navigation request going on, in the boot time we would have lost it, but now if we look at the code, we can now see if maybe we have the response that we're looking for as a preloaded response. As I said, very technical topic. There's the link with all the technical details, but this is something that at the scale of Facebook does make a real difference. It's, as I said, an origin trial right now, so you have to be part of this origin trial to actually experience it. Something that is also very exciting is OneTabSignup and auto sign-in. So first of all, getting people to sign in if they already have an account is a major hassle. But then getting people to the first stage that they even do have an account, it's like the worst. And this is something that the OneTabSignup API tries to solve. So a lot of you probably have been here. You're at this login screen, and you're like, should I log in with Google? Or actually, what even is that? Or should I maybe use Facebook? But if I do that, maybe will this app post something to my Facebook profile or to my Google Plus profile? Or what even does it do? Is it like, oh, there's a password field, maybe I should fill out that, but what is the email address that I use? Or did I even sign up? So it's like so many open questions that these screens kind of express. So maybe you forgot your password, which is something that most commonly happens. So you're like, nah, that's not really the experience I want to give to my users. And this is where the OneTabSignup API comes in. So it's live now. So before it was in closed beta, now it's all live. You can see the URL at the bottom. And if you follow along the navigation here in the little animation, you can see I'm browsing to that page. Then the page shows this little widget, signing in with my Google profile. And below all this is a protocol called OpenYOLO. You only log in once. Great name, OpenYOLO. So essentially what it does is it takes the Google profile from the browser and makes that available to the page as a user that you can use and authenticate your user and sign them up automatically. So very exciting API. How would you use that? So you first configure some authentication methods, auth methods. As I said, this is based on an open YOLO protocol. Right now it's implemented by Google. So actually, if you look at the variable names, you can see here it's called Google YOLO for this particular implementation. And supported methods are ID and password or just Google.com account. And likewise for the supported ID token providers, it's the Google.com account URL. And then you have an ID from the developer console. And how would you then do that? You can see there's two methods. One is for auto sign in, which is the first one, Google YOLO retrieve, and then you pass it that options object from above, or the more exciting one, the auto sign up, Google YOLO hint, which would then show to the user this little widget that you can see down here, where people just can use this profile to then sign up to the service. Very exciting, and a lot of new advertisers and publishers who are working with this already. Next topic, as I said, this is a collection of topics really. What's next for the web? A ton of things. Storage estimation. Something that is very exciting about PWAs is obviously offline, so you can take things, cache them for offline use. But in many cases, you're not sure how much even can I cache. So if you are a video application, for example, is it a good thing to download maybe 1 gigabyte of 500 megabytes of video? Definitely not on mobile, but maybe on Wi-Fi. But is it a good idea from the storage that I have available? And this is where the new storage estimate API comes in. So you can essentially just, before making an operation, check on your service, do you have, in your service worker or in your app logic, do I have enough storage available for making this? And if you then look at, you can see here it's interpolated in the string, estimate usage and estimate quota. You can say how much do I already have used and how much can I use. So then you can calculate the delta and see does it make sense or not to actually go for storing this 500 megabytes of video or not. So pretty exciting API. Next big topic, and talking of video, media-related APIs. And there we have the image capture API, because in many cases when you take images from users, you might want to zoom in on what matters. And before, you could not really do actual hardware zoom, but now you can do hardware zoom if your camera allows it, so some cameras do, or you can switch different cameras. For phones that have actually 2 cameras built in, and this is not software zoom, this is really hardware zoom. So you are connecting to the camera zoom, and from the web, can change the zoom settings. You can see here I was just experimenting with this in the office. So yeah, I'm zooming in on what actually does matter, and this is my big nose and my teeth and whatnot. So yeah, this is hardware directly access from the camera APIs. So how would you do that? Essentially, you have a number of things that you need to initialize. So you have, from a media stream, a video track. And this track has certain capabilities. And this track, these capabilities then have settings. That the track has settings that it can then use. And then finally, we need the slider. So this little slider here, we get a reference to the slider. And then we need to set the bounds. So we check what is the zoom minimum, what is the zoom maximum for creating the minimum and maximum zoom values. And then we can see to what fine-grained or not steps we can zoom in or out. And based on that, we can then apply the constraints directly to the track when the input event on the input, so on the slider, is being triggered. So very exciting, and this is something that wasn't available on the web before, but now it is. Shape detection API. That's also something that is pretty amazing once you've seen it or once you've tested it. Shape detection API allows you to detect faces, read barcodes, and even do OCR, optical character recognition, right from the browser. And what you can see here is a little demo where I'm just looking at different websites and barcodes. Here we go. So we are scanning this QR code here. And you can also see we are looking at faces. There's this person's face detected, and then there was a region of text detected. And the cool thing is this is directly embedded in the browser. So you get, without any calling external services or whatnot, or including QR code detection, JavaScript libraries, you get directly the high-level information on your browser. So first, how do you do that? You need to initialize the different detectors. So if you need all of them, you obviously initiate all of them. So face detector, text detector, and barcode detector. And you can see here, it's just a simple new, and then whatever detector you want to get. And then you just have a video element, and you iterate over all of them, so over all detectors, with this video in reference. And it's a promise-based API, so you can actually just do this in parallel. And then when you have the detected faces, detected text, and detected barcodes back, you can then do something with it and iterate over them and, I don't know, draw, as in the demo, little rectangles or squares around the detected areas, or obviously for text, read out the text that was detected. Super easy, super high-level API that is directly available in the browser. Media session API. So when you're playing video content or audio content from web, this API now allows you to show meaningful metadata to the user. What you can see in this animation here is the Android widget that is generated. And if you look, it has a ton of useful information here. So if you swipe down again, whoop, here we go, you can see it has, first of course, all the meta information, like it has the image of the track that is playing right now, it has the title, it has the length, and so on. So you get from web a super rich integration directly into this widget. And it's not distinguishable from something like, let's say, Spotify or something, where you would directly experience and await this kind of integration, but now it's possible on web as well. If we zoom in, you can see what is possible. So we have metadata.title, we have artist and album, we have artwork, and then we can set different handlers and make them available and accessible directly from the widget. So we can go a couple of seconds forward, you can go to the next track, you can pause and play, obviously. So very rich integration here. And then essentially all you need to do is you have one big object of the metadata. So it looks a bit scary, but actually it's not. It's just a bunch of text, so title, artist, album, then an array of different sized preview images or thumbnail images, because on different devices, the browser may select the different sized option ones so that you get the one that is looking the most crisp on the particular device. And then you can just connect the different handlers to the action. So play, pause, seek backward, seek forward, previous track, and next track. And of course, this is just dummy functions here, but you can then, of course, connect with your native player API and make that happen. Talking again of video or media in general, sometimes when you have the choice of displaying different video streams, it might not make, in all cases, sense to play the best. So if you imagine 4K video, that's huge, that's a lot of data, but does it actually play smoothly? So with the CanPlay APIs, something you can get is a rough estimate. Can this play at all? Like, is the codec supported? But then in many cases, you're more interested in can it play smoothly and can it play power efficiently? What you notice here is, of course, there's like a theme. Not all devices are the same. And what people tend to forget is not everyone is on the latest generation device. Not everyone has a Pixel 2 or whatever, iPhone 10. A lot of people also have last generation or last generation Android devices. And in this case, playing the best quality that theoretically the device does support might not always be the best idea. So there's no code snippet with it, but essentially what you can see in this little screenshot, it's pretty small, I guess, but we give it an object here where we say, this is the video stream with this and that bitrate and this and that codec, and then you get live output. This configuration is supported, smooth, and power efficient. So you can, like that, give it different configurations of video streams that your service has available, and then based on the one that plays smoothly and power efficiently, you can decide on one. You can also obviously combine this with a battery API. So if you notice the person is like really low on battery, it might not be the greatest idea to play something that might be able to play smoothly, but not power efficiently. So you can obviously combine all the different APIs if they are available and exposed and do something meaningful. Next exciting topic, web VR, because sometimes real reality isn't real enough. Just imagine the possibilities for people like home designers, if you are whatever IKEA of this world, and you integrate with WebVR, you can just say, this is the piece of furniture, upload a picture of your home, or just a quick zoom around of your home, and then with WebVR, you could, on the fly, create something like this, where people could experience with whatever VR goggles or cardboards they have at their homes, how this piece of furniture would look like. This is obviously not super simple to do, but the code here gives you some pointers to high-level APIs that make it a little bit easier, but just web VR, this is a very powerful concept that you can now directly have VR experiences right from the browser. So this is a demo, by the way, from Martin Splitt. So they have built something along these lines of interior designers and how would things look like. Performance-related APIs. So what kind of performance information can you get? And the first and foremost, most important information typically is how fast can you go, so that you get network information. This has been in browsers for a while, but now finally it's really useful, because before it would tell you person is on a Wi-Fi network or person is on a mobile network, but you wouldn't really get any meaningful data, because everyone knows being on a hotel Wi-Fi can actually sometimes be worse than being on edge. So the absolute information is typically not so useful. What we have now is something like effective type, so where you can get the real speed estimate. So if you are on a slow hotel Wi-Fi, for example, it will tell you, well, it's a Wi-Fi network, but actually the effective type might just be 2G. So this is a lot more useful, and you also get things like round trip times, you get downlink max, so the upper bound of the downlink in theory. So you can combine this theoretical network type with the actual effective type that you get out. Why might this be useful? Well, you could do something that is commonly not super straightforward to do, but now it would be. You could combine media queries and look at the actual effective type speed that you have right now. So with media queries, you can get information about the device. So you can say, does this device support Retina? So is it a Retina display using Apple terms here? So you could look at the min device pixel ratio and at the min resolution. And there's actually a way to match media queries programmatically from JavaScript. So if you have this information, so supports Retina, you can then combine it with, is the actual network connection right now permitting 4G, is it permitting Retina graphics, or is the effective type maybe 4G? And if so, then you use Retina graphics, and else you go down for something a little slower. This is actually something that AMP does, Accelerated Mobile Pages. So I'm wearing an AMP t-shirt right now. So we look at different signals. We look at, is it a fast network? Is it also a device that supports high-res graphics? And then we take these two experiences together, and if we have fast network and a high-end device, then it makes sense to actually deliver a high-end resolution graphics. But sometimes it might just be the better experience for the user to get something at all. Maybe it's a little low res, but still it's something, rather than not getting anything at all. So quite powerful if you think about the things that this unlocks. The next topic is the performance API, because you should, or in many cases you actually do care about load times of your actual users. So you can see here there's in the window.performance object timing information that you can get. And then you can essentially just look at this timing information and calculate things like load time, like connect time, and render time. So you can see here it's all essentially end times minus the start times. So you can see in this object you get different fields, and like that you can create this little table of page load time, connect time, and render time. And if you wanted to, you could then of course feed this back to your whatever analytical service, and like that get meaningful real-world user exposure of how fast or not is my page actually. So very powerful things that this API unlocks. And sometimes you also want to see how fast is my page actually painting. So how fast is it rendering? And for this, you can now register a performance observer. And in this performance observer, you can look for the different events that are observed by this API. And you might be interested in looking at the paint events. And if you initialize this performance observer at the very beginning of your page, you can then just iterate as soon as your actual content on the page gets rendered. And like that, you can get very meaningful data of real-time painting information directly on your users' devices out in the wild and not in your labs, where you might not have the typical user setup of network. So you can see what I'm doing here. I'm observing the different paint events here, and I'm just iterating over all of them, and you can see what is in there. First paint, first contentful paint. So really very meaningful metrics. So first paint is the event when something appears on the screen at all, and the first contentful paint is the more meaningful, obviously, of the two events. It's when something useful in the sense of that the person could start reading or could start consuming the page actually happens. So maybe changing the background color from white, which would be the browser default, to blue could be the first paint, but then the first text appearing could be the first contentful paint. So very meaningful metrics, of course, that you should really track over time. And you can see here, this is not hard to do. This is very easy. You can also, just like this, not even use the performance observer, but just after the fact, get these metrics. And another theme in this topic is client hints. So where you can see what kind of device the person is using. In Chrome, we run Chrome metrics, and what we found is for a number of browser tab crashes, so where the tab just crashes, in the end, what was the issue was that the device was out of RAM. Not all of the devices have like 2 gigabytes or 3 gigabytes of RAM or even more. There's a lot of lower end devices that have maybe not even 1 gigabyte of RAM. So if you detect that such a device is accessing your page, and you can see one of the example devices here. You can then decide to serve more of a light version. So if you have maybe a game, you can serve lighter textures, for example. And like this, really adopt the user experience to what the person's device is. This is something that is available directly as an HTTP header. So you can say in your server, I'm a server and I accept client hints. And you can see the server can send this as a header here, accept -ch for client hints. And then you can say, what kind of client hints do you support? Device memory. And then the user agent, so the browser that accesses whatever resource on the server, can say, I'm a device and I have memory of 0.5 gigabyte. And like this, the server can then dynamically adopt whatever it delivers back. And like this, really make the experience tailored to the user's device. Or you can also use this from a JavaScript context. So in modern browsers, there's also navigator.deviceMemory, which would give you the same information, or navigator.hardwareConcurrency, where you can also say, I'm a low memory device with maybe just 2 cores instead of whatever 4 cores or 8 cores that you find on modern phones. By the way, fun anecdote here. I was using this on this device, and yeah, I am in the lucky position to have a high-end device that has 16 gigabytes of RAM, and it was only supporting, only reporting 8 gigabytes of RAM. So I found a bug, and actually it's working as intended, because what they do is they cap the reported memory at 8 gigabytes. If you have more, they say it's too much of a possibility to use this for device auditing and device fingerprinting. So if you have more memory, it will only report 8. And obviously this is a moving target, so in a couple of years, maybe 8 gigabytes will be low end and 16 gigabytes will be mid end or whatnot. So yeah, this is just fun anecdote. If you test this on a desktop, don't be surprised if it's only 8 gigabyte if you have more. Yeah. Web means obviously JavaScript. So in the next couple of slides, we look at a number of new JavaScript features. And something that is very important and very cool recently is that you can use imports. But imports are only one thing of the equation. Something even more exciting is dynamic imports, which allow you to lazy loading of scripts that you only need when certain things happen. So you can see here in this little code example, I have a button, and when someone clicks that button, we can dynamically import the JavaScript that is responsible for making this button do something meaningful. So this could be for something that not many users use on your page. So let's say you have an experience for your page that is by default in the browser language that the browser header reports. But maybe sometimes people want to override that. So you notice only 10% of my users change the language to something that is different from the browser language. And like that, you could connect the code that makes that happen, like pulls in, I don't know, the language flipping modules and so on dynamically. You could then now, with this new API, do that. And obviously, it's a promise-based API because loading code takes a little while. So then, when the thing fulfills, you have dialogbox.open in this particular case, or you could also just catch the error in case of something goes wrong. So very exciting. Sometimes when you work with streams or just in general async data, working with this can be really nasty. So one of the new things we have is, of course, async and await, which helps a lot. But sometimes we might even do something more advanced. So you can see here this for await loop that uses this magic function. It's kind of course, pseudocode, but this magic function is an asynchronous function that gives me, for example, a chunk of data back from a response that is here awaited dynamically, and it yields then the length of the chunk. So I can do that until I have the entire chunk read, the entire response body read, and like that, you can see this is all asynchronous code, but looking at the code, it's just essentially, very straightforward to read because it reads and feels like synchronous code. And something you probably didn't notice at the first moment was this async function star. So this little star here makes this a generator function. Very exciting new JavaScript feature. And the final thing that is new is finally in promises. Because in many cases, you need to do something in both cases, if the promise fulfills or if the promise rejects. So let's say we have a function that fetches some information from somewhere, so we always want to show the loading spinner. But then, in some cases, the loading may work. In some cases, the loading may not work. So what we can do now is we can say, finally, whatever happens, if the thing fulfills or if the thing rejects, we always want to hide the loading spinner and set the text of the element, whatever it may be, to either the response text or, in this case, the error message. So you can see whatever finally gets is either the result of the catch or of the then case here. So very useful because it simplifies a lot of the code. And else you would have to have the loading spinner code in the fulfill and in the reject. So violation of the do not repeat yourself method. Okay, with all this software stuff, finally over to hardware stuff. Something that is in browsers for quite a while, but now actually like really available, so not behind flags, so is the Web Bluetooth API, which allows you to communicate with nearby Bluetooth devices. This demo here is from a colleague of mine, François Beaufort, and he's one of our hardware persons. So you can see here how from his phone, which actually runs just a website, so you can see the URL bar here, he's controlling Bluetooth candles. It's not the most useful demo, but you get the point. You can just, with loading a website, control nearby Bluetooth devices. Obviously, it's all HTTPS, and you need to be sure to actually be on the network and be approving of the communication. And if that is the case, you can then directly from this website control the Bluetooth experience. I didn't mention any code here because it would be too complex, but again, there's URLs where you can see some of the examples in action. And where there's Bluetooth, there's also USB. So this is another demo. This comes from Kenneth Road Christiansen, where he is connecting to a nearby web USB device, which is, I think, an Arduino board that is connected to his computer over USB. And from this website, he's connecting to it via web USB. So you can see he's sending text here that is then being displayed on this dot matrix display here. Again, not the most useful demo, but you get, again, the point, what this kind of integration would allow you to do, especially for any kind of homebrew hardware that you have at home, where you could just connect to a simple web server, connect low-end things on the device just by going to a website. Something important to point out is this is obviously not for any and all USB devices, but only specifically designed web USB devices. And as always, this is HTTPS only, so it's powerful features that only get unlocked if you have a powerful network connection, which means an encrypted network connection. This is not the end, so we're always living in what is the present, and at some point we look to the future, and then this new future will become the present. So very philosophical here, but if you want to stay up to date, there's /web/updates, where you can always subscribe to the newest and hottest and greatest. With that, thank you very much for listening. This was not just me, this also contained some slides from Steven Sonnev, who is the PM working as a product manager working on the OneTabSignup API. So thank you very much. Exactly 45, so I think it's lunch now, right? Yes. I'm around for questions if there are some. I'm not sure how strict we are with the lunch queue, or...
I don't know, whatever. If you're hungry, you can go.
Else I will be here in the Firebase hackathon all day, so feel free to just talk to me. Thank you again.